The race between American shipyards and German U-boats. November 12, 1942, Richmond, California. The welding torch sparked and hissed as metal to metal, her hands steady despite the November chill and her exhausting double shift. Around her, the Kaiser Richmond Shipyard No. 2 roared with the sound of 10,000 workers doing the impossible, building an entire cargo ship in less than a week. It was 11:47 p.m. In 13 minutes, history would be made. Mary had been a secretary at an insurance company in Oakland 4 months ago. Now she was a welder, one of thousands of Rosie the Riveters who'd flooded into West Coast shipyards when men went to war. Her husband Tom was somewhere in the Pacific, a radio man on a destroyer. She was building the ships that would supply him, feed him, arm him, and maybe, if they built enough of them fast enough, bring him home alive. The hull section she was working on would become part of the SS Robert E. Peary, the 47th Liberty ship to be launched from this yard. But unlike the 46 ships before it, the Peary would set a record that would seem impossible to anyone who understood shipbuilding. Keel laying to launch in 4 days, 15 hours, and 29 minutes. 111 hours and 29 minutes to build a 441-foot, 7,176-ton ocean-going cargo vessel. The ship wouldn't be completely finished at launch. That would take another week for outfitting. But the feat was unprecedented, and it was meant to send a message to 2 audiences. To American workers to show what they could accomplish when pushed to the absolute limit. And to Admiral Karl Donitz and his U-boat wolf packs in the Atlantic to demonstrate that no matter how many ships they sank, America would build more. The Battle of the Atlantic wasn't being fought just with depth charges and torpedoes. It was being fought in shipyards like this one, where the real question wasn't whether American industrial might could produce enough ships to win the war. The question was whether they could produce them fast enough to avoid losing it first. At midnight, Mary Leavitt set down her torch, checked her work, and moved to the next section. All around her, the shipyard pulsed with organized chaos. Cranes swinging hull plates into position, rivet guns chattering like machine guns, arc welders flashing like lightning in a steel thunderstorm. Someone shouted that they were ahead of schedule. Someone else yelled that they needed more welders on Section 47. The shift supervisor was racing between workstations with a clipboard, checking off completed tasks like a man possessed. Nobody in that shipyard knew whether what they were doing actually mattered. Nobody knew if the Robert E. Peary or any of the thousands of Liberty ships being built across America would arrive in time to change the course of the war, or if they were all just building floating coffins for the North Atlantic. But they built anyway. Because the alternative, surrender, defeat, a world dominated by Hitler's Reich, was unthinkable. This is the story of that race. Not just the Robert E. Peary, but all 2,710 Liberty ships built between 1941 and 1945. The story of how America gambled everything on a radical experiment in mass production, and how that gamble nearly failed before it succeeded. The story of the men and women who built ships at impossible speed, and the men who sailed them knowing they might never come home. It's the story of the most important manufacturing achievement of World War II. More important than the B-29, more important than the atomic bomb, more important than radar or penicillin. Because without the Liberty ships, none of those other achievements would have mattered. Without the Liberty ships, Britain starves, Russia falls, the war is lost. And for 2 years, from 1941 to 1943, it looked like that's exactly what was going to happen. Chapter 1. The Arithmetic of Catastrophe. Captain Sir Frederick Bolton, Royal Navy, had been fighting U-boats since 1917. He'd survived the First World War, commanded convoy escorts through the 1920s and 30s, and in September 1939, when Hitler invaded Poland, he was recalled from retirement to do it all again. By November 1940, he wanted to quit. Not from cowardice. Bolton had earned 2 distinguished service orders in the Great War and had never lacked courage. But courage was useless against mathematics, and the mathematics of the Battle of the Atlantic were brutal and unarguable. Bolton commanded a convoy escort group based in Liverpool, protecting merchant ships making the desperate run across the Atlantic from North America. His office was a cramped space in a requisitioned warehouse, and the walls were covered with charts tracking ship movements, U-boat sightings, and losses, especially losses. The chart for November 1940 showed 146,613 tons of shipping sunk. October had been 152,169 tons. September, 295,335 tons. In the first 3 months of 1941, German U-boats would sink 792,151 tons. The numbers kept climbing, and Britain's reserves of fuel, food, and ammunition kept falling. At current loss rates, Bolton's logistics officer told him in January 1941, we have approximately 14 months before Britain becomes unable to continue the war. 14 months. That was how long Britain could survive at the current rate of ship losses. Less if the Germans increased their U-boat production. Less if wolfpack tactics became more effective. Less, and this seemed increasingly likely, America chose not to enter the war. The problem wasn't just that ships were being sunk. The problem was that British shipyards couldn't replace them fast enough. Traditional shipbuilding methods took 6 to 8 months per vessel. Each ship required thousands of skilled workers, riveters, fitters, welders, painters, joiners. Britain had the workers, barely, but they lacked the raw materials. Steel production was already dedicated to building tanks, aircraft, and warships. Dedicating more steel to merchant ships meant fewer weapons to fight with. And even if Britain somehow built enough ships to replace the losses, where would the sailors come from? Each torpedoed merchant vessel meant 40 to 50 men dead or captured. Experienced seamen were becoming as scarce as ships. Captain Bolton studied his charts and understood that Britain was losing a race it couldn't afford to lose. U-boats were being built faster than escorts could sink them. Torpedoes were hitting targets faster than shipyards could replace them. The mathematics were inexorable. At some point in 1942 or early 1943, the curves would cross. Germany would be sinking ships faster than the Allies could build them. And when that happened, the war would be over. Britain would surrender not because German armies invaded, but because the British people would be starving in a nation that had run out of fuel, ammunition, and hope. There was only one possible solution, and everyone knew it. America had to enter the war, and American shipyards had to start producing cargo ships at rates that had never been achieved in human history. Not 6 months per ship, not 3 months. They needed to build ships in weeks, dozens of ships every month, hundreds every year. It's impossible, Bolton's logistics officer said. Bolton didn't disagree, but he wrote the report anyway, calculating exactly how many ships would need to be built, how fast, to merely hold the line against U-boat sinking. The numbers were staggering. 600 to 800 cargo ships per year, possibly more. Each ship 10,000 tons, capable of carrying 10,000 tons of cargo across the Atlantic. The report went up the chain to the Admiralty, then to Churchill's War Cabinet, then across the Atlantic to Washington. British officials met with American counterparts and made their case with the desperation of men who knew they were asking for a miracle. Britain needed America to build an entire merchant fleet. needed it immediately, and needed it done faster than anyone had ever built ships before. The Americans, remarkably, said yes. But saying yes and actually delivering were very different things, and for the first 2 years of the program, it looked like the promise had been made in vain. The ships would be built too slowly, arrive too late, and the Battle of the Atlantic would be lost before America's industrial might could matter. Chapter 2. The Man Who Had Never Built a Ship. Henry John Kaiser was 59 years old in 1941, a self-made industrial magnate who'd made his fortune building roads, dams, and bridges. He'd been a primary contractor on the Hoover Dam, the Grand Coulee Dam, and the San Francisco-Oakland Bay Bridge, massive infrastructure projects that had employed thousands and transformed the American West. He had never built a ship in his life. When the U.S. Maritime Commission issued contracts for emergency cargo vessels in early 1941, months before Pearl Harbor, traditional shipbuilders dominated the bidding. Companies like Todd Shipyards, Bethlehem Steel, and Newport News had been building ships for decades. They knew the trade, had the skilled workers, understood the complexities. Kaiser ignored all of that and bid anyway. His pitch was audacious. He would build ships faster and cheaper than anyone else by treating shipbuilding not as a craft but as a manufacturing process. He would use mass production techniques adapted from automotive factories and dam construction. He would hire unskilled workers and train them for specific, repetitive tasks. He would build ships from prefabricated modules that could be assembled like giant Lego blocks. He would use welding instead of riveting because welding was faster and required less skill. The Maritime Commission was skeptical. So were the traditional shipbuilders, who warned that Kaiser had no idea what he was getting into. Ships weren't automobiles. They weren't dams. They were complex, floating structures that had to withstand enormous stresses from waves, cargo loads, and, in wartime, potential combat damage. Cutting corners to save time would produce ships that would fall apart at sea. Kaiser listened to the criticism and ignored it. He secured contracts to build 30 cargo ships at his Richmond, California shipyard and promised delivery times that made experienced shipbuilders laugh. 4 to 5 months per ship, less if possible. The laughter stopped when Kaiser actually started building ships. His first challenge was finding a design. The British had already developed a simple, sturdy cargo ship called the Ocean Class, a no-frills workhorse designed for mass production. The Maritime Commission adapted this design with input from Gibbs and Cox naval architects, creating what would be called the EC2-S-C1, Emergency Cargo 2 400 to 400 feet, Steam Engine C1 design designation. It wasn't pretty. Admiral Emory Land, the Maritime Commission chairman, called it a dreadful-looking object. President Roosevelt, touring a shipyard, described one as looking like an ugly duckling. The Liberty ship, named for Roosevelt's For Freedom speech, was 441 feet long, 57 feet wide, with a single deckhouse amidships and 5 cargo holds capable of carrying 10,856 deadweight tons. The ship used a triple expansion steam engine, an obsolete design from the turn of the century, specifically because simple engines could be operated by inexperienced crews and didn't compete with military vessels for modern turbine engines. Traditional shipbuilders built ships from the keel up, one piece at a time, riveted together by skilled workers on a slipway. The process took 6 to 8 months because every step had to be completed sequentially. Kaiser threw out that entire approach. He divided each ship into hundreds of prefabricated sections, hull plates, deck sections, bulkheads, deckhouses, that could be manufactured simultaneously in different parts of the shipyard. While workers built one ship on the slipway, other crews were building the sections for the next 3 or 4 ships in fabrication shops. When a section was complete, a 10-ton hull panel for instance, it was moved by crane to the slipway and welded into place. The ship quite literally grew like a building, being assembled from enormous prefab components. Welding was key to the entire process. Traditional riveting required teams of 4 skilled workers, 2 inside the hull, 2 outside, working in cramped, difficult conditions. A good riveting crew might place 200 to 300 rivets in a day. One welder could do the equivalent work in 2 hours. Welding also had a hidden advantage. It was teachable. A person with no shipbuilding experience could be trained to weld in a few weeks. They wouldn't be great welders, but they'd be adequate for structural work. An army of adequate welders could outproduce a smaller group of master riveters. Kaiser hired everyone: farm workers, housewives, high school kids, elderly men past draft age, women who'd never worked outside the home. By late 1942, Kaiser's Richmond yards employed 90,000 workers, running 3 shifts, 24 hours a day, 7 days a week. The workers weren't just building ships, they were racing against death, though most didn't realize it yet.
Chapter 3. The Wolf Packs. Korvettenkapitän Heinrich Bleichrodt stood in the conning tower of U-109, scanning the horizon through Zeiss binoculars as the November sun set over the North Atlantic. The sea was relatively calm, which was unusual for this time of year. Most November crossings were hellish affairs: 40-foot waves, gale-force winds, temperatures below freezing. But tonight the ocean was almost peaceful. Swells maybe 10 feet, wind less than 20 knots. Perfect hunting weather. "Contact, bearing 275, range approximately 12 kilometers, called his watch officer. "Multiple targets, appears to be a convoy." Bleichrodt suppressed the excitement he felt. He'd been hunting for 3 days since departing Lorient, his U-boat base on the French coast. 3 days of empty ocean, rationed food, stale air, and mounting frustration. Now, finally, prey. He studied the horizon. Yes, there, black dots against the darkening sky. Smoke from cargo ship stacks. He counted at least 15, maybe 20 vessels. A decent-sized convoy, probably heading from Halifax or New York to Halifax or Glasgow. Loaded with food, fuel, weapons, ammunition. Everything Britain needed to keep fighting. Everything Bleichrodt's orders told him to sink. "Signal to BDU," he ordered. "Contact report. Convoy SC-52. Grid position EN-48. Approximately 20 merchants, heading east, pursuing." The radio operator sent the signal to Befehlshaber der Unterseeboote, U-boat command, in occupied France. Within hours, Admiral Dönitz would vector other submarines to this position. The wolf pack would assemble, and when darkness fell completely, they would attack. This was the system that had made the Atlantic a graveyard. Individual U-boats would locate convoys and shadow them, reporting their position. Other boats in the area would converge, forming a patrol line across the convoy's path. Then, at night, when visibility was poor and ASDIC sonar was less effective, they would attack on the surface, using their diesel engines for speed and maneuverability. The British had tried everything to stop it. Escort vessels zigzagged around convoys, pinging with sonar, searching for submerged U-boats. But the Wolfpack tactics exploited a weakness: surface attacks at night. U-boats on the surface were nearly invisible, and their low profile made them almost impossible targets for escort guns. Bleichrodt had been doing this since 1940. In 2 years, he'd sunk 23 Allied ships, totaling 148,000 tons. He was good at his job, very good, and he felt no particular guilt about it. This was war. The British were trying to kill German soldiers. He was trying to starve the British nation. It was impersonal, mathematical, necessary. But lately, Bleichrodt had noticed something disturbing. The convoys were getting larger. In 1940 and 1941, a typical convoy might be 20 to 30 ships. Now, they were running 40, 50, sometimes more than 60 merchants in a single convoy. More ships meant more targets, but it also meant something else. The British weren't running out of shipping. Despite 2 years of devastating losses, despite U-boats sinking hundreds of thousands of tons every month, there were more Allied cargo ships at sea now than there had been at the start of the war. How is this possible? Bleichrodt had asked Admiral Dönitz during his last visit to headquarters. We're sinking them faster than they can be built. The mathematics are clear. Dönitz showed him intelligence reports from agents in America. The reports described massive shipbuilding programs, new shipyards appearing along the American coasts, tens of thousands of workers building cargo ships at unprecedented rates. The reports claimed some American yards were launching ships every few weeks. They're called Liberty ships, Dönitz had explained. Simple cargo vessels, mass-produced. The Americans think they can build their way to victory. Can they? Bleichrodt had asked. Dönitz had paused before answering. That's what we're trying to determine. If we can sink ships faster than they can build them, Britain starves and the war ends. If they can build faster than we can sink, we lose the Atlantic. Everything depends on the rate of production versus destruction. So, it's a race. Exactly. And we intend to win it. Now, watching the convoy steam slowly across his field of view, Bleichrodt understood that he was part of something larger than individual ship kills. Every merchantman he sank was one less ship carrying supplies to Britain, yes, but it was also a data point in a larger calculation. Could Germany sink ships fast enough to overcome American production? The mathematics were brutal. In 1941, Allied and neutral ships totaling 4.3 million gross tons had been sunk, 2,171 ships. But new construction had replaced only about 1.2 million tons. That meant a net loss of 3.1 million tons of shipping. If that rate continued, Britain would run out of ships by mid-1943. But there was a problem with that calculation. It assumed American production would remain constant. Intelligence reports suggested it wouldn't. The Americans were building more shipyards, hiring more workers, implementing mass production techniques that were supposedly cutting construction time from months to weeks. Could they really do that? Bleichrodt was skeptical. Shipbuilding wasn't like manufacturing cars or radios. Ships were complex, dangerous structures. Shortcuts would produce vessels that would break apart in storms or founder in rough seas. The Americans would learn that lesson the hard way, he thought. Convoy has begun evasive maneuvers, reported the watch officer. They've spotted us. Submerge to periscope depth, Bleichrodt ordered. We'll shadow until nightfall, then surface and attack. U-109 slipped beneath the waves, leaving only its periscope cutting through the water. Around him, Bleichrodt knew other U-boats were converging on the same prey. By midnight, perhaps 6 or 8 submarines would be positioned around the convoy. Then the slaughter would begin. It always did, and it would continue until either Britain surrendered or America ran out of steel to build ships. Bleichrodt intended to make sure it was the former.
Chapter 4. Learning to Weld in 4 Weeks. Rose Martinez had never held a welding torch in her life before September 1942. She'd been a seamstress in Los Angeles, making dresses for department stores, earning $18 a week. Good money for a single woman, enough to rent a small apartment and send a little home to her mother in Mexico. Then her 2 brothers were drafted. One went to the Army, one to the Marines, and Rose decided she needed to do something to help win the war. She saw a poster at the post office. Women needed for war work, good pay, free training. The poster showed a woman in coveralls and a welding mask creating a shower of sparks. Below it said, Richmond Shipyards, Kaiser Industries. Rose applied the next day. She was hired the day after that. Now, 4 weeks later, she was standing on a scaffold 40 feet above the ground, welding hull plates on what would become Liberty Ship number 672, SS William Gaston. Her hands were steady despite the fear. Her welds were clean despite having only a month of training. And she was earning $0.95 an hour, nearly $40 a week, more money than she'd ever made in her life. The training had been intense. Kaiser had built a special welding school adjacent to the shipyard. New hires spent 4 weeks learning one thing and one thing only: how to make good welds on steel plate, nothing else. They didn't learn ship design, structural engineering, or naval architecture. They learned to hold a torch at the correct angle, move it at the correct speed, and produce welds that would hold 2 pieces of steel together. You don't need to understand why the weld is there, their instructor had told them on the first day. You just need to make it good enough that the ship doesn't fall apart. It was the opposite of traditional apprenticeship, where workers spent years learning every aspect of a trade. This was extreme specialization. Take a complex task, break it into hundreds of small tasks, train people to do just one task, assemble them in the correct sequence, and watch ships emerge from chaos. Rose's job was specific. She welded vertical seams on hull plates. That was it. She didn't weld horizontal seams. That was someone else's job. She didn't weld curved sections or complex joints. Just vertical hull plate seams, all day, every day, 6 days a week, sometimes 7. The first week she'd been terrible at it. Her welds were uneven, full of inclusions and weak spots. The inspectors rejected half her work, and she had to grind out the bad welds and start over. She went home every night exhausted, her arms aching, her eyes burning from the arc flash, convinced she'd be fired. But the foreman had been patient. Everyone's terrible at first, he told her. Just keep practicing. Muscle memory will develop. You'll get faster and better. He was right. By the 3rd week, Rose's rejection rate had dropped to 10%. By the 4th week, she was as good as welders who'd been doing this for months. Her hands had learned what her brain couldn't fully understand: the correct angle, the correct speed, the correct distance from the metal. Now, standing on the scaffold with her torch hissing, Rose worked her way down a vertical seam between 2 massive steel plates. The trick was to keep the torch moving at a constant speed while feeding the welding rod into the molten puddle of metal. Too fast and the weld would be weak. Too slow and you'd burn through the metal. The sweet spot was maybe 3 to 4 inches per minute, steady and smooth. The work was dangerous. Rose had seen accidents, people falling from scaffolds, getting burned by molten metal, being crushed by swinging hull sections. One woman in her training class had lost 3 fingers when a crane cable snapped and a steel plate shifted. Another worker had been electrocuted when his welding equipment shorted out in a rain puddle. But Rose couldn't think about the danger. She had a quota, 20 feet of vertical seam per shift. That was the number Kaiser's efficiency experts had calculated was achievable by a trained welder. Some days she made it, some days she didn't. The days she didn't, she felt like she was personally responsible for delaying the ship and losing the war. Around her, the shipyard was a scene of controlled chaos. Cranes swung hull sections weighing 10 tons or more, positioning them with remarkable precision. Rivet guns chattered. Kaiser still used some rivets for critical joints where welding wasn't sufficient. Arc welders flashed constantly, thousands of them across the yard, creating a perpetual lightning storm of industrial might. The noise was overwhelming. Between the rivet guns, the welding, the cranes, the cutting torches, the giant steam hammers forming hull plates, and 10,000 workers shouting to be heard over the machinery, the shipyard operated at a volume that made conversation impossible without shouting directly into someone's ear. Rose had learned to communicate with hand signals. Everyone had. A pointed finger meant, "Pass me that tool." A circular motion meant, "Lower the crane." A slashing motion across the throat meant, "Shut down the equipment, something's wrong." An entire vocabulary of gestures had developed because speech was useless. The work was also relentless. Kaiser ran 3 8-hour shifts, but there was pressure to work overtime. The shipyard operated 24/7, and there was always a need for more welders. Rose often worked 10 or 12-hour shifts, and twice she'd worked 16 hours straight when the yard was behind schedule. The money was good. Her paycheck last week had been $51.75, including overtime. But she earned every penny. Her hands were covered with small burns. Her back ached from standing on scaffolds. Her eyes were perpetually bloodshot from the welding flash, even with the protective masks. She'd lost 12 pounds since starting the job because she was too tired to eat properly. But she kept showing up. Because her brothers were somewhere in the Pacific fighting Japanese soldiers, and the ship she was building would supply them, protect them, maybe save their lives. Every weld she made was a small contribution to their survival. And there was something else, something Rose had never experienced before: pride. She was good at this. In 4 weeks, she'd learned a skilled trade and was producing work that inspected engineers approved. She was earning more than most men had earned before the war. She was part of something enormous, 10,000 workers building ships that would win the war. "Martinez, section complete," her supervisor shouted from below. "Move to section 47B. Rose shut off her torch, checked her work one last time, and climbed down the scaffold. On to the next seam, and the next, and the next. 20 feet of weld per shift. 6,000 Liberty ships to build. 14 million tons of steel to be joined, one bead at a time. Somewhere in the Atlantic, U-boats were sinking the ships that earlier welders had built. Rose didn't know if her work would arrive in time to matter. She only knew she had to try.
Chapter 5. The Breaking Point. The SS Schenectady broke in half on January 16, 1943, while tied to a dock in Portland, Oregon. Not during a storm, not after being torpedoed, not from running aground. The ship literally split in two while sitting peacefully at dock in calm water, making a sound one witness described as like a giant rifle shot. The fracture ran completely across the deck, just aft of the bridge. The bow section tilted forward, the stern section tilted back. Within seconds, a brand new Liberty ship, launched just 5 weeks earlier, never having carried a single ton of cargo, had become 2 separate pieces of floating scrap. Miraculously, no one was killed. The ship was in port, not at sea, and most of the crew was ashore. The few workers aboard felt the deck shift, heard the terrible cracking sound, and ran to safety before the sections fully separated. But the implications were catastrophic. If Liberty ships could break in half in calm water at dock, what would happen when they encountered North Atlantic storms, or heavy seas in the Pacific, or the stress of combat damage? The news spread quickly through the shipbuilding community. Traditional shipbuilders, who had warned from the beginning that Kaiser's mass production methods were dangerous, pointed to the Schenectady as proof they'd been right. Welding was unreliable. Unskilled workers couldn't produce quality results. The entire Liberty ship program was built on a foundation of structural weakness. Within days, other Liberty ships began developing cracks. Not full fractures like the Schenectady, but serious stress cracks in hulls, decks, and bulkheads. Inspectors found cracks in ships still under construction. Ships at sea radioed that they discovered cracks during rough weather. The SS Esso Manhattan developed a crack that extended completely around the hull, a full circumferential fracture, but somehow held together long enough to limp into port. By March 1943, more than 1,000 Liberty ships had reported structural cracks of varying severity. 20 ships had suffered major fractures. 3 had broken completely in half like the Schenectady. The Maritime Commission faced a nightmare scenario. the entire Liberty ship fleet might be fundamentally unsafe. The investigation was urgent and comprehensive. Teams of engineers examined failed ships, analyzed welds, studied the steel, and tested hull sections under stress. What they discovered was both reassuring and terrifying. The good news: the basic Liberty ship design was sound. The problem wasn't the concept of mass-produced cargo ships. The bad news? The execution had serious flaws that were killing ships. Problem 1. Brittle steel. The steel used in Liberty ship construction had been produced rapidly in massive quantities, and quality control had sometimes been sacrificed for speed. Some steel batches had high sulfur content, which made the metal brittle at cold temperatures. When Liberty ships encountered cold North Atlantic water, the steel lost ductility and became prone to fracture. This was compounded by the fact that Liberty ships used steel that met minimum specifications but no better. Traditional shipbuilders had used higher-grade steel with safety margins. Kaiser had used the cheapest acceptable steel to save money and speed production. Problem 2. Welding defects. The 4-week welding training program produced welders who were adequate but not excellent. Many welds contained small defects, inclusions, porosity, incomplete fusion. Individually, these defects weren't catastrophic. But when hundreds of defective welds existed throughout a ship, they became stress concentration points where cracks could initiate. Traditional riveted construction had been more forgiving. If one rivet failed, the load transferred to adjacent rivets. But welding created continuous joints. If a weld failed, the crack could propagate across the entire structure. Problem 3. Design features that concentrated stress. Liberty ships had square hatches, rectangular cargo hole openings. This was practical for loading cargo, but from a structural engineering perspective, it was terrible. Square corners concentrate stress. Every hatch corner was a crack initiation point waiting for the right conditions to fail. The ships also had abrupt changes in structural stiffness. Areas where thick, heavily reinforced sections met thinner, less reinforced sections. These transitions concentrated stress and provided pathways for cracks to propagate. Problem 4. Welding-induced stress. Welding generates enormous heat, and as the metal cools, it contracts. This creates residual stress in the structure. In a properly designed welded ship, these stresses are distributed and managed. But Liberty ships, built at high speed by inexperienced welders, had accumulated residual stresses throughout their structures. Add cold temperatures, heavy seas, and cargo loads, and those residual stresses could exceed the steel's fracture strength. The solution required multiple changes. Immediate fix: crack arresters. Engineers designed simple steel straps that were welded across the top edges of cargo hatches and at other stress concentration points. These crack arresters wouldn't prevent cracks from forming, but they would stop cracks from propagating across the entire ship. It was a crude solution, but it worked. Ships with crack arresters installed could survive fractures that would have sunk them otherwise. Material improvement: better steel. The Maritime Commission tightened steel specifications, requiring lower sulfur content and better quality control. This added cost and slightly slowed production, but it produced steel that was less brittle at cold temperatures. Welding reform: better training and inspection. Kaiser extended welding training from 4 weeks to 6 weeks and added more comprehensive inspection procedures. Welds that would have been accepted in 1942 were now rejected and redone. The rejection rate increased from 15% to nearly 30%, but the quality of accepted welds improved dramatically. Design modifications: rounded corners. New Liberty ships incorporated rounded hatch corners instead of square ones. Existing ships had reinforcing straps added to distribute stress around hatch corners. These changes didn't eliminate stress concentration, but they reduced it enough to prevent catastrophic failures. The fixes worked. By mid-1943, the rate of serious structural failures had dropped dramatically. Ships still developed cracks occasionally, but catastrophic fractures became rare. But the damage to the program's reputation was done. Merchant mariners looked at Liberty ships with suspicion, wondering if the vessel they were boarding would break in half in the next storm. U-boat commanders heard about the structural problems and specifically targeted Liberty ships, assuming they were more likely to sink from relatively minor damage. And the traditional shipbuilders had their vindication. Mass production methods were inherently dangerous. Quality couldn't be achieved at speed. The attempt to build ships in weeks instead of months had produced floating death traps. Henry Kaiser, facing criticism from all sides, made a characteristically bold response. Instead of slowing production or switching to traditional methods, he accelerated the fixes while maintaining the high production rate. Rather than admit defeat, he'd prove that mass production could produce quality ships if properly executed. The SS Robert E. Peary, the ship built in 4 days, 15 hours, 29 minutes, had been a publicity stunt to demonstrate what was theoretically possible. Now Kaiser needed to prove that the Liberty ship program could produce thousands of reliable, safe ships that would survive the war. The race wasn't just against U-boats anymore. It was against the clock, against structural physics, and against the skeptics who said it couldn't be done.
Chapter 6. The Mathematics of Murder. Admiral Karl Dönitz kept meticulous records. In his headquarters at Carnival, near Lorient on the French Atlantic coast, he maintained detailed charts tracking every U-boat patrol, every ship sunk, every ton of Allied shipping sent to the bottom. The walls of his operations room were covered with maps showing convoy routes, U-boat positions, and most importantly, the graph that told the story of the entire Atlantic War. Cumulative shipping losses versus Allied construction. On March 15, 1943, Dönitz studied that graph with grim satisfaction. The lines had finally crossed. In March 1943, German U-boats would sink 627,377 gross register tons of Allied shipping, 108 ships. Allied shipyards would launch approximately 528,000 tons of new construction. For the first time in the war, Germany was sinking ships faster than the Allies could replace them. "This is it," Dönitz told his staff. "This is the tipping point we've been working toward. If we can maintain this rate for 6 more months, Britain will be forced to capitulate. Their stockpiles of food and fuel are critically low. Their merchant fleet is in decline. 6 months of sustained pressure and the war is over." The numbers supported his optimism. Germany now had 400 operational U-boats, with more launching every month. The boats were getting better. New Type VIC submarines with increased range and reliability, Type IXC long-range boats that could operate in distant waters, and experimental Type X-21 submarines that promised revolutionary underwater performance. The crews were experienced. The tactics were proven. The Wolfpack system was operating at peak efficiency. U-boats were sinking an average of 5.8 ships per patrol, an extraordinary success rate that was bleeding the Allied merchant fleet white. But Dönitz also saw warning signs in the data that troubled him. First, Allied escort tactics were improving. Convoy escorts were using new radar sets that could detect surfaced U-boats at night, the time when Wolfpacks had previously operated with near impunity. Aircraft were appearing further out in the Atlantic, operating from bases in Iceland and Newfoundland with extended range. The air gap in the mid-Atlantic, where U-boats had operated without fear of air attack, was shrinking. Second, the quality of convoy escorts was improving. In 1941 and early 1942, convoys had been protected by a few overworked destroyers and corvettes. Now, escort groups had specialized training, better equipment, and aggressive commanders who had learned to hunt U-boats effectively. The average time from first ASDIC contact to depth charge attack had dropped from 12 minutes to less than 3. That meant U-boats had less time to evade. Third, and most concerning, was the rate of U-boat losses. In 1941, Germany had lost 35 U-boats. In 1942, 85 U-boats. In the first 3 months of 1943, 47 U-boats had been sunk. If that rate continued, Germany would lose more than 180 U-boats in 1943, nearly half the operational fleet. The mathematics were becoming troubling. U-boat construction was running at about 20 boats per month. U-boat losses were approaching 15 per month. That meant a net increase of only 5 boats per month. Not enough to maintain the offensive pressure needed to starve Britain. And then there was the American shipbuilding program. Dernitz's intelligence staff had compiled reports from agents in America, from aerial reconnaissance, from interrogated prisoners. The reports all said the same thing. American shipyards were producing cargo ships at rates that seemed impossible. They're claiming some yards are launching ships every week, Dernitz's intelligence officer reported. Multiple ships per week from individual yards. If these reports are accurate, American production will soon exceed 1,000 ships per year. That's impossible, Dernitz had responded. No nation can build that many ships. The numbers must be exaggerated. But the evidence kept accumulating. Convoy sizes were increasing. More ships were appearing in Allied colors. The average age of ships in convoys was decreasing, a clear sign that new construction was replacing losses. Dernitz ordered his staff to calculate the break-even point. How many ships did U-boats need to sink to offset Allied construction? The answer was chilling. At current Allied construction rates, U-boats needed to sink approximately 800,000 tons per month just to maintain the status quo. To actually reduce Allied shipping capacity, they needed to sink more than 900,000 tons per month. March 1943's total of 627,377 tons was impressive, but insufficient. U-boats needed to increase their effectiveness by 40 to 50% to actually win the Atlantic War. Can we do it? Donitz asked his operations officer. The officer studied the charts. Theoretically, yes. If we maintain current U-boat numbers, improve our tactics, and the Allies don't substantially improve their anti-submarine capabilities, we can reach 800,000 tons per month. But, sir, all 3 of those assumptions are optimistic. U-boat numbers are growing slowly. The Allies are definitely improving their ASW. And every month we wait, American shipyards are producing more Liberty ships. Dernitz understood the implication. Germany was in a race it might not win. The window of opportunity was closing. If U-boats couldn't achieve decisive results in the next few months, before American shipbuilding reached full capacity, and before Allied anti-submarine warfare became too effective, the Battle of the Atlantic would be lost. He issued orders to intensify operations. U-boats would be pushed harder, kept at sea longer, sent after convoys more aggressively. The crews would be exhausted, but there was no alternative. This was Germany's last chance to starve Britain before America's industrial might made victory impossible. What Donitz couldn't know, was that March 1943 would be the high watermark of the U-boat offensive. All Allied shipping losses in March would never again be exceeded. The tide was about to turn, not because of any single tactical innovation, but because American shipyards were about to unleash a flood of Liberty ships that would overwhelm any conceivable sinking rate. The race between production and destruction was approaching its climax, and neither side fully understood that the outcome would be determined not by battles at sea, but by battles in shipyards. By welders like Rose Martinez, by foremen managing impossible schedules, by engineers solving structural problems, by thousands of workers who would never see combat, but whose labor would be as decisive as any destroyer's depth charges. Chapter 7. The Men Who Sailed Them. Chief Engineer Thomas Whitley stood on the deck of SS Stephen Hopkins in September 1942, watching the pre-dawn sky and wondering if he'd see another sunrise. The Hopkins was a Liberty ship, one of the first, launched from Kaiser's Richmond Yard in April 1942. She'd made one successful Atlantic crossing, delivering war supplies to Britain, and was now on her second voyage, this time heading south around Africa to deliver cargo to Egypt and the Soviet Union via the Persian Gulf. It was supposed to be safer than the North Atlantic run. No U-boat wolf packs in the South Atlantic. Fewer German submarines, period. The Hopkins had sailed as part of a small convoy, but storms had scattered the ships, and now they were alone, 700 miles west of Africa, proceeding at the Liberty ship's maximum speed of 11 knots. Which wasn't fast enough to outrun what Whitley was looking at through his binoculars. 2 ships on the horizon, closing fast. As the sun rose, Whitley could make out details: a German surface raider, probably the Steer, accompanied by a supply ship. Both armed, both capable of sinking an unarmed merchantman with ease. The Hopkins had a single defensive weapon, a 4-inch deck gun mounted aft with a small ammunition magazine. Merchant ships weren't supposed to fight warships. They were supposed to scatter and radio for help while naval vessels came to their rescue. But there was no help coming, no escorts nearby, no friendly warships within hundreds of miles. The Hopkins was alone, and the German raider was closing at 18 knots. They'd be in gun range within 30 minutes. Captain Paul Buck assembled his officers. "Gentlemen, we have 3 options. 1, we surrender immediately. 2, we abandon ship and let them sink us. 3, we fight." "Fight with what?" someone asked. "We've got 1 gun against a raider with multiple guns and armor." "We've got that 1 gun, some brave men who know how to use it, and the element of surprise," Buck replied. "They're expecting us to surrender or run. They're not expecting us to fight." He paused. "I'm not ordering anyone to stay. This isn't the Navy. You're merchant mariners, not combatants. Anyone who wants to abandon ship can do so now, no shame in it." Nobody moved. "All right then," Buck said. "Let's give them a fight they won't forget." The battle that followed would become one of the most remarkable actions of the entire war. The SS Stephen Hopkins, an unarmed cargo ship manned by merchant mariners who'd never fired a shot in combat, engaged 2 German warships in a daylight surface action. The 4-inch gun crew, led by Ensign Kenneth Willett of the Naval Armed Guard, opened fire at maximum range. Their first salvo was short. The second was over. The third hit. The German raider Steer returned fire with its superior weapons, and the Hopkins began taking hits almost immediately. Shells smashed through the thin steel hull, detonating in cargo holds, starting fires. The bridge took a direct hit, killing Captain Buck and several officers. The engine room was struck, and superheated steam filled the space, scalding 3 men to death. But the gun crew kept firing. They scored hit after hit on the Steer, damaging its hull, knocking out several weapons, starting fires that the German crew struggled to contain. They hit the supply vessel, forcing it to withdraw. They kept firing even as the Hopkins was dying beneath them, even as German shells tore the ship apart. Chief Engineer Whitley, badly wounded, kept the engines running until a shell exploded in the engine room and killed him. The gun crew fired until their ammunition ran out, then continued with their sidearms. When the ship began to sink, they fought on, firing their personal weapons at the German crew until the water took them. The SS Stephen Hopkins sank at 10 a.m., taking 15 of her crew with her, including Captain Buck, Chief Engineer Whitley, and Ensign Willett. The survivors, 42 men, took to lifeboats and drifted for 31 days before being rescued near Brazil. 19 men would die in the lifeboats from wounds, exposure, and dehydration. The German raider Steer, heavily damaged by the Hopkins gunfire, became uncontrollable due to fires and flooding. Her captain ordered her scuttled. The Steer sank later that day. The supply ship managed to rescue the German crew and limped back to port, but never returned to operational service. The SS Stephen Hopkins, an ugly, ungainly, mass-produced Liberty ship that critics claimed was structurally unsound and built by unskilled workers, had fought and sunk a German warship designed for combat. She'd been destroyed in the process, but she'd taken her enemy with her. The story of the Hopkins spread through the merchant marine like wildfire. It proved that Liberty ships weren't helpless victims. With brave crews and determination, even an unarmed cargo ship could fight back. But it also illustrated the terrible vulnerability of merchant mariners. These men weren't soldiers. They didn't wear uniforms in combat. Under international law, they were supposed to be treated as non-combatants. But U-boats torpedoed them without warning. Surface raiders shelled them. The ocean killed them just as dead as any bullet. The casualty rate for merchant mariners during World War II was staggering. Of approximately 250,000 American merchant mariners who served during the war, 9,521 were killed in action, a casualty rate of 3.8%. That was higher than any military branch except the Marine Corps. 1 in 26 merchant mariners didn't come home, and most of them died on Liberty ships. Not because Liberty ships were unsafe, although the structural problems certainly didn't help, but because Liberty ships made up the bulk of the merchant fleet. More Liberty ships meant more targets for U-boats. More Liberty ships meant more merchant mariners at risk. Every Liberty ship that slid down a launching way in Richmond or Portland or Baltimore was a promise to Britain, "We will keep you supplied." But it was also a death sentence for some percentage of the crew who would sail her. The mathematics were unavoidable. Produce 2,700 Liberty ships, put 45 crew on each, and some proportion of those 121,000 men would die in the Atlantic or Pacific. The men knew it. Every merchant mariner who boarded a Liberty ship knew the statistics. 1 in 26 wouldn't come home. Those weren't great odds. But they boarded anyway, because somebody had to deliver the supplies. Somebody had to keep Britain from starving. Somebody had to haul the tanks and trucks and ammunition that would win the war. The Liberty ships couldn't sail themselves. They needed engineers like Thomas Whitley to keep the engines running. They needed captains like Paul Buck to navigate through danger. They needed ordinary seamen willing to go to sea knowing they might never return. And in shipyards across America, workers like Rose Martinez were building the ships as fast as they could, hoping that the men who sailed them would survive to deliver their cargo.
Chapter 8. Black May. U-boat Korvettenkapitän Herbert Werner stood in the conning tower of U-230, watching depth charges explode around him. The charges weren't close enough to damage the boat, but they were close enough to be terrifying. Fountains of water shooting skyward, the underwater pressure waves making U-230's hull ring like a bell. The crew inside wondering which explosion would be the one that crushed them. It was May 17, 1943, and Werner had been hunted for 18 continuous hours by an escort group that seemed determined to kill him personally. "Destroyer bearing 030, range decreasing," called the watch officer. "He's making another run." "Dive, dive, take her to 90 meters, Werner ordered. U-230 slipped beneath the waves, but Werner knew it was futile. The escort had radar. They had ASDIC sonar. They had Hedgehog forward-throwing depth charges that could sink a U-boat before it could evade. They had training, experience, and, most importantly, they had time. They could hunt him all day and all night if necessary. Werner had been at sea for 37 days, hunting convoys in the North Atlantic. In those 37 days, U-230 had sunk exactly 0 ships, not one. In 1941 or 1942, a U-boat patrol of that length would typically sink 6 to 8 merchantmen. Now Werner would be lucky to make it home alive. Something had changed in the Atlantic, something fundamental. The convoy he'd attacked 2 days ago had been protected by an escort group that seemed impossibly large. 8 destroyers and corvettes, plus air cover from long-range aircraft that appeared every few hours. When U-230 had tried to approach on the surface at night, the standard Wolfpack tactic, radar-equipped escorts had detected them at 6 kilometers and immediately charged to attack. Werner had been forced to dive, and while submerged, he couldn't catch the convoy. By the time he surfaced again, the convoy was gone, and an aircraft had spotted him. He'd spent the next 6 hours crash diving and evading. Then he tried to join a wolf pack attacking another convoy.
Before he could get into position, 3 escorts had appeared and driven him deep with depth charges. He'd spent 14 hours underwater, running silent, conserving battery power, while the escorts hunted him with ASDIC. When he finally surfaced to recharge batteries, a radar-equipped Liberator bomber had appeared out of nowhere and nearly sunk him with depth charges. Werner had gotten U-230 underwater with seconds to spare, and now he was being hunted again, this time by what sounded like 4 destroyers. "Depth charges incoming," shouted the sound operator. Werner braced himself. The explosions were closer this time, close enough to shatter light bulbs and shake loose equipment. The hull groaned. A small leak appeared in a pipe joint, spraying water. The crew worked frantically to stop it, while Werner maneuvered the boat, trying to evade the next barrage. This continued for 3 more hours. Depth charges, evasive maneuvers, silent running. The battery charge dropping toward critical levels. The air inside the boat becoming fouled with carbon dioxide. Men gasping for breath. The temperature climbing to 40 degrees Celsius from the heat of packed bodies and machinery running without ventilation. Finally, mercifully, the escorts gave up. Perhaps they were low on depth charges. Perhaps they'd been called to protect another convoy. Werner didn't know and didn't care. He waited until full darkness, then surfaced U-230 to recharge batteries and ventilate the boat. The crew stumbled onto the deck, gasping in fresh air, grateful to be alive. Werner sent a radio report to BDU. Attacked convoy SC-129, unable to reach firing position due to aggressive escorts and air cover. Driven deep, no ship sunk, returning to base. It was the kind of report that had become depressingly common in May 1943. U-boats were still finding convoys, but they couldn't sink them. The escorts had become too effective. The air cover was too pervasive. The tactics that had worked in 1941 and 1942 were no longer viable. Werner didn't know it yet, but May 1943 would become known as Black May in U-boat service. In that single month, 43 U-boats would be sunk, more than 10% of the entire operational fleet. U-boat losses exceeded new construction for the first time. The exchange rate, ships sunk versus U-boats lost, had turned decisively against Germany. And Allied ship production was accelerating. In May 1943, American shipyards would launch 140 Liberty ships. British yards would add another 30 cargo vessels. Total Allied production, approximately 1.2 million tons of new shipping. German U-boats would sink 264,852 tons in May 1943, less than 1/4 of new construction. The curves on Admiral Donitz's chart had crossed again, but this time in favor of the Allies. For every ship U-boats sank, Allied shipyards were launching 4 replacements. The mathematics that had briefly favored Germany in March had inverted. Now, the numbers were brutal in the opposite direction. On May 24, 1943, Donitz made the most difficult decision of his career. He ordered all U-boats to withdraw from the North Atlantic. The battle that he had fought for 3.5 years, the campaign that had nearly starved Britain into submission, was over. Germany had lost. The U-boats would continue to operate in other areas, the South Atlantic, the Indian Ocean, coastal waters, but the Battle of the Atlantic was decided. Britain would not starve. The supply line to North America would remain open. American troops and equipment would flow to Europe in unlimited quantities. And the Liberty ships that had made it possible would continue rolling off the assembly lines at unprecedented rates, carrying the material that would destroy the Third Reich. Herbert Werner survived the war, one of the few U-boat commanders who did. In his memoir, published decades later, he wrote about the moment he realized the battle was lost. Quote, "We had been hunting ships, but the ships had become infinite. No matter how many we sank, more appeared. It was like fighting the ocean itself. Kill one wave and another comes. Kill that one and 10 more are behind it. We never had a chance. We just didn't know it until May 1943. Chapter 9. The Turning Point. Henry Kaiser stood on a platform overlooking his Richmond Shipyard No. 2 in August 1943, watching 3 Liberty ships under construction simultaneously. All 3 would be launched within the next 10 days. Another 4 ships were in various stages of assembly. Parts for 8 more ships were being fabricated in the yard's workshops. 5 years ago, this shipyard didn't exist. It had been empty land on San Francisco Bay. Now it employed 90,000 workers, operated 24 hours a day, and was producing ships faster than any facility in human history. Kaiser's other yards in Richmond, Oregon, and Vancouver, Washington were equally productive. Together, his operations were launching approximately 1 Liberty ship every day. Other shipyards across America were matching or exceeding those rates. Bethlehem Fairfield in Baltimore had launched 508 Liberty ships by war's end. New England Shipbuilding in Maine would produce 267. The Southeast was building them, the Gulf Coast was building them, the West Coast was building them. In 1943, American shipyards would launch 1,896 merchant ships, totaling 19.3 million deadweight tons. That was more tonnage than the entire British merchant fleet at the start of the war. More tonnage than Germany could possibly sink, even if every U-boat worked perfectly and faced no opposition. The industrial might of America, fully mobilized and directed toward ship production, had become an unstoppable force. Kaiser had proven his critics wrong. The traditional shipbuilders who'd said mass production couldn't work, who'd predicted catastrophic failures, who'd claimed unskilled workers would produce garbage, they'd been wrong about all of it. Yes, there had been problems. The Schenectady fracture and subsequent cracking issues had been serious, but Kaiser's engineers had solved them. The crack arresters worked, the improved steel was better, the enhanced welding training produced quality results. Liberty ships were now proven reliable. They weren't pretty, but they were functional. They crossed the Atlantic, delivered their cargo, and came home. And when U-boats sank them, which still happened regularly, American yards built replacements faster than the losses mounted. The statistics told the story. 1942. Liberty ships launched 597. Total U.S. merchant ship production, 8.1 million deadweight tons. Allied shipping losses, 7.8 million tons. 1943. Liberty ships launched 1,896. Total U.S. merchant ship production, 19.3 million deadweight tons. Allied shipping losses, 3.2 million tons. The crossover point had arrived. America was now producing more than 6 times the tonnage being sunk. The merchant fleet wasn't just being sustained, it was growing. Every month, more ships were afloat than the month before. The stranglehold on Britain had been broken. But Kaiser wasn't celebrating. He was doing arithmetic. The war in the Pacific required enormous shipping. Every American soldier in the Pacific needed approximately 4 tons of supplies per month: food, ammunition, fuel, equipment. With millions of men deployed across thousands of miles of ocean, the logistical demands were staggering. The planned invasion of Europe, D-Day, would require even more shipping. Thousands of ships to transport men and equipment across the Atlantic, then to sustain the armies in France. The Mediterranean campaign needed ships. The supply route to Soviet Russia needed ships. The Alaska-Siberia air ferry route needed support shipping. Kaiser calculated that America needed at least 5,000 merchant ships to meet all requirements. They had approximately 3,000 as of August 1943. That meant 2,000 more ships needed, plus replacements for combat losses and routine maritime accidents. "Can we do it?" Kaiser's production manager asked. Kaiser studied his charts. Current production rate approximately 140 ships per month across all American yards. At that rate, 2,000 ships would take 14 months, late 1944. The military wanted them by mid-1944 for D-Day. "We need to increase production by 50%, Kaiser said. "Get me 200 ships per month, and we can hit the targets." "That's impossible. We're already at maximum capacity." "Then we'll expand capacity, build more ways, hire more workers, add more shifts, whatever it takes." And they did. By early 1944, American shipyards were launching an average of 3.3 ships per day, more than 100 per month. The peak came in March 1944, when American yards launched 169 merchant ships in a single month. The implications went beyond simple statistics. The shipbuilding program had become a training ground for industrial workers who would form the backbone of America's post-war economy. Welders like Rose Martinez, managers who'd learned to coordinate thousands of workers, engineers who'd solved unprecedented problems, all of them were gaining skills and experience that would reshape American industry for decades. The program had also demonstrated what American industrial capacity could achieve when fully mobilized. When Pearl Harbor was attacked in December 1941, skeptics thought America couldn't possibly produce enough war material to defeat Japan and Germany simultaneously. The Liberty Ship program proved them wrong. If America could build 2,700 cargo ships in 4 years, it could build anything in any quantity. More subtly, the program had changed social dynamics in America. Women like Rose Martinez had proven they could do men's work and do it well. African Americans, largely excluded from industrial jobs before the war, had been hired in large numbers and demonstrated equal competence. The shipyards had been one of the first places where these social barriers had broken down, and the changes would ripple through American society for generations. But in August 1943, Kaiser wasn't thinking about social change or post-war implications. He was thinking about ships. Every ship built was a promise kept to the men fighting overseas. Every ship launched was one more nail in Hitler's coffin. He watched a Liberty ship slide down the launching way into San Francisco Bay, and he thought about the crew that would sail her, the cargo she'd carry, the battle she'd supply. Somewhere in the Atlantic, a U-boat might sink her. Somewhere in the Pacific, a Japanese submarine or aircraft might send her to the bottom. But before she sank, 10 more would be launched, and before those 10 sank, 100 more would be built. America had unleashed an industrial tsunami that no enemy could withstand. The race was over. America had won. The only question now was how long it would take for Germany and Japan to realize it.
Chapter 10. Life Aboard a Liberty Ship. Able seaman Robert Thompson stood his watch on the bridge wing of SS James Oglethorpe, scanning the horizon for U-boats in the pre-dawn darkness of February 1944. The North Atlantic in winter was miserable, temperatures below freezing, 30-foot seas, winds gusting to 50 knots. The Oglethorpe rolled and pitched violently, and Thompson had to hold tight to keep from being thrown across the deck. He'd been sailing Liberty ships for 8 months, his third ship after the first 2 had been torpedoed. He'd survived both sinkings, 20 minutes in freezing water the first time, 4 hours in a lifeboat the second time, and both experiences had left him with a healthy respect for the ocean and a deep fatalism about his chances of surviving the war. "How long have we been out?" asked Henderson, the other watchstander. 14 days since Halifax, Thompson replied. "Another 4 to Liverpool if the weather holds and nobody shoots at us." "Weather's not gonna hold. Look at that sky." Thompson looked. Henderson was right. The western horizon showed a wall of dark clouds advancing toward the convoy. They were in for a storm, probably a bad one. Liberty ships were notoriously poor seaboats. Their flat bottoms and boxy design made them efficient cargo carriers, but terrible in heavy seas. They rolled violently even in moderate swells. In a real storm, they were torture chambers that tested the endurance of the toughest sailors. The storm hit 3 hours later. By noon, the Oglethorpe was laboring through 40-foot seas with winds screaming at 60 knots.
Green water broke over the bow with every wave, flooding the forward deck. The ship would climb a wave, hesitate at the crest, then crash down into the trough with a shudder that made the whole vessel groan. Thompson was in his bunk, off watch, trying to sleep. It was impossible. The ship's motion was so violent that he had to wedge himself into the bunk with spare life jackets to avoid being thrown to the deck. Every few seconds, the ship would drop into a trough and everything not secured would fly into the air, then crash down when the ship hit bottom. The noise was overwhelming. The wind howled. The seas crashed against the hull. The cargo, Sherman tanks and trucks, shifted in the holds despite being heavily secured, creating banging and grinding sounds that made everyone nervous. If the cargo broke loose, the ship could roll over and sink within minutes. Worse was the sound of the ship itself. Liberty ships had been built quickly by inexperienced workers, and they protested loudly in heavy weather. Hull plates groaned, welds creaked, rivets popped with sounds like gunshots. Every sailor on a Liberty ship knew about the Shenectady and the other ships that had broken in half. Every time the ship made an unusual sound, every sailor wondered if this would be the moment their ship fractured. Thompson finally gave up on sleep and went to the mess deck for coffee. The cook was performing miracles, keeping hot food available despite the ship's violent motion. Thompson watched him work. The cook had secured himself to the stove with a rope around his waist, and he timed his movements to the ship's roll, pouring coffee when the deck was level and holding on when the ship rolled to 35 degrees. "How bad is it?" Thompson asked. "Bad enough," the cook replied. "Heard the captain on the radio. 3 ships have lost steering. One broke her back, she's sinking. Another got hit by a wave that stove in her bow plates. The convoy scattered. We're on our own until the weather clears." Thompson absorbed this without reaction. It was normal for Liberty ship convoys. The ships simply couldn't maintain formation in heavy weather. They were too slow, their steering was too imprecise, and their flat bottoms made them uncontrollable in big seas. Every convoy lost ships to weather, sometimes more than to U-boats. The storm lasted 3 days. When it finally abated, the convoy reformed, or tried to. Of the 43 ships that had left Halifax, 39 were still afloat and able to proceed. 2 had sunk in the storm. 2 had been so damaged they turned back to port. The Oglethorpe had survived with minor damage. Some deck plates buckled, a lifeboat smashed, the forward mast bent 15 degrees out of true. Nothing that prevented the ship from continuing to Liverpool. But the experience had taken a toll on the crew. They were exhausted, battered, and increasingly convinced they wouldn't survive the war. Thompson had signed on for 1 voyage, 4 months, 1 round-trip Atlantic crossing. That had been 8 months ago. He'd been on 3 ships, survived 2 sinkings, and was now wondering how many more times he could cheat death before his luck ran out. The Merchant Marine had no term limits. Unlike military personnel who served defined enlistments, merchant mercenaries signed on for individual voyages. Legally, Thompson could refuse to sign on for another trip after the Oglethorpe reached Liverpool. Nobody would call him a coward. Nobody would court-martial him for desertion. But somebody had to sail the ships. If everyone refused, Britain would starve and the war would be lost. So Thompson knew he'd sign on for another voyage, and another, until either the war ended or his luck ran out. Life aboard a Liberty ship wasn't glamorous. The quarters were cramped, 8 men to a cabin, with bunks stacked 3 high. The food was institutional and monotonous. The work was hard and dangerous. The pay was good, $100 a month base pay, plus bonuses for war zones, but no amount of money could compensate for the constant fear of torpedoes, the brutal weather, and the knowledge that 1 in 26 merchant mercenaries wouldn't survive. The Navy Armed Guard, young sailors assigned to man the defensive guns on merchant ships, had it even worse. They were typically 18 or 19 years old, fresh out of boot camp, assigned to vessels that had no armor, no military organization, no escape if the ship was torpedoed. Their job was to shoot at aircraft or U-boats with hopelessly inadequate weapons, usually a single 4-inch gun aft and a few 20mm anti-aircraft guns, while knowing that if the ship sank, they'd go down with her. Thompson had become friends with several of the armed guard sailors on the Oglethorpe. Good kids, mostly, scared but trying not to show it. They manned their guns during every alert, staring at empty horizons and hoping they wouldn't have to fight. In 8 months at sea, Thompson had seen armed guard crews fire their weapons in anger exactly twice. Once at a U-boat that submerged before they could score a hit, once at a German reconnaissance aircraft that flew past at high altitude, well out of range. The rest of the time, they just waited. Waited for torpedoes that might never come. Waited for attacks that might happen or might not. Waited to either reach port safely or die at sea. That was life on a Liberty ship in 1944. Mostly boring, occasionally terrifying, always uncertain. The ships themselves were crude but functional. They got you across the ocean if you were lucky. The accommodations were basic but adequate. The work was hard but not unmanageable. But the fear never went away. Every sailor on every Liberty ship knew the statistics. Knew that ships were still being sunk, even though the worst of the Battle of the Atlantic was over. Knew that mines, submarines, aircraft, weather, or just bad luck could send them to the bottom at any time. And yet, they sailed. Because somebody had to. Because the alternative was defeat. Because every cargo delivered was one more step toward victory. Thompson finished his coffee and headed back to his cabin for a few hours of sleep before his next watch. Outside, the North Atlantic rolled and heaved, gray and cold and merciless. The Oglethorpe plowed through the swells, her single propeller churning, her obsolete steam engine pushing her toward Liverpool at 11 knots. 11 knots! Barely faster than a man could run. In an ocean full of submarines that could travel at 18 knots. On a ship built in 45 days by workers who'd learned their trades in a few weeks. Thompson fell asleep wondering, as he did every night, whether he'd wake up, or whether a torpedo would kill him while he slept. It was the uncertainty that wore you down, not knowing whether you had days or years left to live, whether the next convoy would be routine or catastrophic, whether your ship was one of the lucky ones or one of the 200 Liberty ships that would be sunk before the war ended. He slept anyway, because what else could you do? The ship sailed, the war continued, and somewhere in America, workers were building more Liberty ships. 2. Faster than they could sink. The race between American shipyards and German U-boats. Prologue. November 12, 1942, Richmond, California. The welding torch sparked and hissed as Mary Lavitt brought metal to metal, her hand steady despite the November chill and her exhausting double shift. Around her, the Kaiser Richmond Shipyard No. 2 roared with the sound of 10,000 workers doing the impossible, building an entire cargo ship in less than a week. It was 11:47 p.m. In 13 minutes, history would be made. Mary had been a secretary at an insurance company in Oakland 4 months ago. Now she was a welder, one of thousands of Rosie the Riveters who'd flooded into West Coast shipyards when men went to war. Her husband Tom was somewhere in the Pacific, a radio man on a destroyer. She was building the ships that would supply him, feed him, arm him,